Hello everyone and welcome to my talk on how Django can help reduce top 10 security vulnerabilities that are listed in OWASP. In the process of building a web application, security measures are not often taken into account by web developers, especially when we are working with security experts. We tend to let them deal with the global aspect of security, which is not always ideal. In this talk, we will explore some of the most prevalent OWASP vulnerabilities and how to mitigate them in Django. Django is chosen for this talk because it is one of the top 10 web development framework for years, and of course it has object relation mapper and it enables SQL queries with Pythonic syntax. Django was built to minimize the security risk and to also give developers the ability to avoid and reduce the vulnerabilities by themselves by using best practices. Let's see how. Now let's dwell into what is OWASP. Open Web Application Security Project is a non-profit foundation that works to improve the security of software. OWASP Top 10 is a standard awareness document for developer and web application security. It represents a broader census about the most critical security risks to web application. In other words, it is an annually updated list of 10 most critical web security risks. The list is put together by a team of security experts from all over the world. The data come from a number of organizations and then analyzed. Using these top 10 is perhaps the most effective first step towards changing the software development culture, and it helps in producing more secure code. Let's have a look at them one by one. The top candidate here is broken access control. Access control enforces policies such that user cannot act outside of their intended permissions. Failures typically lead to unauthorized information disclosure or modification or destruction of data. Now, broken access control allow attackers to bypass authentication and perform tasks as though they were privileged users. For example, a web application could allow user to change which account they are logged into as simply by changing the path of URL, and this is not getting verified. There are different types of examples which can help us in understanding the broken access control. Let's say we have an API that changed the entity, or we are allowing user to log in without actually authenticating it, or we are allowing the user to change the access token itself, or we have the unauthorized or untrusted origins for APIs. Of course, bypassing ACL checks by modifying the URL is a very traditional example of it. Access control can be secure by ensuring that a web application uses authorization tokens and sets tight control on them. Django helps us deal with such situation by supporting JWT authentication, where we have separate authentication servers, and it also provides permission classes that helps ensuring that the permission is flowing down the hierarchy and not leaking anywhere. The next one is cryptographic failures. This is the risk of data being accessed without the appropriate authorization. It is always good practice to discuss the aspect of data at the beginning and all throughout the project. Questions such as what data are most important, how should data be processed, or etc. All these questions should often be put on the table. Now, first thing to determine here is the protection need for data in transit and at rest. When we talk about data in transit, we are talking about password, credit card numbers, personal information, business secrets that require extra protection, mainly if that data falls under privacy law. For all such data, we have to ask ourselves, is there any data transmitting in clear text? This concerns protocols such as HTTP, SMTP, FTP, which are not using TLS, and we have to make sure that we are not relying on the external internet traffic, because it can be very malicious. We have to verify internal traffic as well if we are the DevOps person. Of course, we have to make sure if the encryption is enforced via HTTP header security directives, or is there any header missing. All these questions come into the picture when we are talking about cryptographic failures. Django can be configured to serve pages only over HTTPS, which reduce risk of data being exposed and then hijacked. It is a good idea to add these mentioned settings in the settings file to ensure HTTPS is used. Beyond the Django, we can use web server to ensure that the received server certificate and the trust chain properly validating. Now let's talk about data at rest. This is about the data that is residing in the storage or in the database itself. So we have to check, is there any weak or the old cryptographic algorithm that it is using, or is there protocol which shouldn't be used in the legacy code. Of course, we have to see if the encryption is enforced in the sensitive data as well. That means if you are having files, are they properly getting controlled via ACLs? The passwords are properly hashed. You are using the algorithms like bcrypt, Argon, or PBKDF2. Django uses PBKDF2 by default because it helps in mitigating the brute force attacks. But if you want to change that, you can always use the password hasher setting in the settings file. Now let's look into the injection attacks. The first one is SQL injection. It routinely tops OWASP top 10, and for good reason. Most web applications consist of a user interface that connects to one or more of the database. And when these kind of data get breached, the total cost is immense. Injection simply means inserting a piece of code that will be executed inside the system. For example, a SQL injection vulnerability let a hacker execute an arbitrary SQL code in our database and get full control over our system. Now, let me give you an example. Whenever we want to run a SQL query in Django, the best practice is to use the built-in ORM query set API. Although there are certain scenarios where you would like to run raw or custom SQL. In such cases, it is recommended to use Manager that will create a raw query set instance that can be used just like query set. The two common mistakes that can lead to injection attacks are using string formatting and code placeholders with a raw query. Let's see this example. It is a simple example. User has given us username and password. You are directly using that username and password to fetch the row in database and then check whether it exists or not. Here we are relying on string formatting, and it opens the application to possibility of attackers using a variety of malicious input. This classical example helps us in understand how attacker can exploit it. If attacker just submit a string like 1 equal to 1, which is always true, and then double dash can disable all the further sanitization or validation we have put in SQL. So this way any attacker can effectively bypass the login authentication altogether. One solution is to add quotes around modus like this, but it doesn't make application any safer because the attacker needs to only remove the opening quote Mark quotation marks before inserting a semicolon and then proceeding to any malicious code they wish. The second solution that we have is parameterization in Django via via query set and other built-in ORM functions, or any other framework that can use parameterization. It protects against SQL injection by converting any potential unsafe input into a safe form, like a string, and that will not be treated and executed as code. For example, here we have taken the user input and then we are using it into the query set class. The use of query set class in Django protects us from SQL injection by making sure that all queries that are sent are parameterized so that database can distinguish the SQL code and the values in the query. Now, the second type of injection attack is cross-site scripting. It is when an attacker is able to get web application to display HTML or JavaScript created by himself rather than the one created by developer. These are widely spread concerns for web applications. It allows attacker to run arbitrary JavaScript codes in our browser, steal any authenticated session data, or they can force our visitors to run the malicious JavaScript code. Django have a built-in render function that allow passing of variable into templates before being displayed as HTML. This way, Django protects all the variables in template with HTML encoding by default. Generally, the most important way to mitigate cross-site scripting is to prevent unescaped user input from making it into your application's rendered HTML. Now, the templating system facilitates that by automatically escaping all variable values. If you don't want to escape something, you have to explicitly tell Django not to escape it. Now, one thing which is important to note here is how to secure from DOM-based attack. So in Django, just by adding these following line will ensure that the forms are secure against DOM-based cross-site scripting attacks. Of course, there are other forms of cross-site scripting attacks that we need to watch out, like non-persistent and stored, and they are also common concerns. While Django templating system will catch the vast majority of cross-site scripting attempts, we need to be certain to validate URL attributes and to avoid using Django safe string to mark anything safe without thinking it through. Now, next is insecure design. The insecure design is a broad category representing different weaknesses expressed as missing or ineffective control design. Insecure design is not the source of all of the top 10, but it is responsible for some of the very impactful one. There's a difference between insecure design and insecure implementation. The insecure design cannot be fixed by a perfect implementation, as by definition. It needed security controls which were never created to defend against specific attacks. Now, bad redirection, forwarding, insecure object references. This happens when we expose our resource references without protecting the resources from exploitation. For example, using auto-incrementing primary keys that are exposed in the URL and can let attacker iterate through all the items in database. This is not a safe practice. Django helps us to avoid that by using unique identifier field, that is UUID field, while designing our models. Now, security misconfigurations. This can be a separate talk in itself, but let me summarize few points here. Running your Django app in production, while debug set to true would expose too much valuable information to the public. So we have to make sure that it is false. It not only helps your web server run faster, but it also reduces the risk of malicious attackers seeing error messages that can inform future attacks. Large organizations would often use Git or any kind of version control to assist their development efforts. Using absolute path in setting file will often result in non-working application in some environment. So it is suggested or recommended to use relative path than any kind of absolute path over there. Although it may be tempting to create path strings via string concatenation, doing so is a security risk as well. Of course, you would want to set up your own email host, username, email host password, email settings. In the setting pie, it is unless it is absolutely necessary, make sure that you are setting it in a separate environment file and then fetching it through Django settings module. It helps in keeping our production and dev environment in separate settings file as well. It helps a lot in making sure that no conflicting settings are coming in picture when you are working in dev and production concurrently. Security updates from core teams. This one item is largely outside the domain of web application framework itself. It is about the application's deployment environment. You need to keep up with Python security updates, Django security updates, and keep track of any third-party library you use for security update. You need to disable ports and services you don't use anymore. It is more about maintaining the libraries and the environment in which your code is running up to the security standards. Vulnerable components. Using vulnerable components is something that is getting overlooked a lot during the web application. Django version 2.2 onwards does not allow any kind of document type definition or entity expansion or fetching of external entity. Also, it is important to note that the XML parsing library, that is XML, is widely used and it has known security vulnerability with devastating repercussions. So how to mitigate this effect, because XML is getting used a lot when we are dealing with the third-party responses. So it is recommended to use two other parsing libraries instead wherever possible. First is diffused XML. It is a Python package specifically written to address common vulnerabilities in Python's default XML parsing libraries, and it should be used on any server that parses untrusted XML. Diffuse XPath is similar to diffused XML, but it also protects specifically against entity expansion or denial of services attacks. These two packages greatly reduce the likelihood of DTD retrieval or decompression bomb attacks. Next is authentication failure. It's a good one. This refers to the risk of someone authenticating himself as another user or taking another user's sessions. Confirmation of identity, authentication, and session management is critical to protect against authentication-related attacks. Let's see how Django helps us in here. With default Django session middleware, the framework doesn't allow any session data in the URL. Session IDs are stored as hashes, and this mitigates brute force attacks. While you will still want to ensure your code doesn't expose any direct session data to the user in any way, Django makes it difficult to expose that information. Django built-in authentication always hashes passwords so that they cannot be cracked even if your application is compromised. So as a developer, always use built-in authentication. Apologies for the it is not bulletin, it's built-in authentication. That's my mistake. So as a developer, please always use built-in authentication or simply extend it. Though it provides security, but it also saves you time and effort. Django session ID, as we said, never made available in the URL and also changes after login. Django comes with a fairly robust standard authentication suite, but there are a few pitfalls to avoiding. One is the use of this particular flag, which ensures that the logged in user will be redirected from the login page if accessed directly. If you have to use this flag, make sure that this flag is set to be used in conjunction with this particular function, which is a decorator. It's a permission required. This avoid any kind of redirect loop. Now, ideally, images and favicons should be hosted on a separate domain or subdomain to prevent third-party sites or from asserting whether your user are authenticated by requesting redirect URL to your images. In the nutshell, CDN should be hosted on separate domain. This will make sure that you are not exposing the internal structure of your domain. And in the last, it is a good idea to rate limit the authentication attempts with maybe Django rate limit backend or any rate limit process or library that you want to use. This prevent automated brute force testing of credentials gained from other data breaches. Software and data integrity failures relate to code and infrastructure that does not protect against integrity violations. An example of this is where an application relies upon plugins, libraries, or modules from untrusted sources, repositories, CDNs. So we have to make sure that we are auditing all of them properly. Of course, this particular vulnerability, AAA08 software and data integrity failure, is something about how your environment is getting used rather than or being set up rather than how you are coding or how Django is coming in picture. So let's see the second one. It's about having a insecure CI/CD pipeline. It can introduce potential for unauthorized access, malicious code, and system compromise. Of course, many applications used auto-update functionality, but sometimes it is done without sufficient integrity, and this can help attacker to upload their own updates to be distributed and run on all installations. Another example is where objects are encoded or serialized into a structure that an attacker can see and modify, and so this is vulnerable to insecure deserialization. This threat targets to mainly web applications which frequently serialize and deserialize data. Serialization mainly means taking objects from application and converting them into a format that can be used from another purpose. Deserialization is opposite. So for an example, serialization is sort of like packing furniture away into boxes before a move, and deserialization is like unpacking the boxes and assembling the furniture after the move. An insecure deserialization attack is like having the movers tamper with the content of boxes before they are unpacked. This exploit is the result of deserializing the data from untrusted sources and can result in serious consequences like DDoS attack or remote code execution. While steps can be taken to catch the attacker, but it is better not to use any kind of third party for this. This category is to help and detect, escalate, and respond to active breaches. But how can we ensure that we have sufficient login in place? We have to make sure that we are auditing all the events that should be properly logged and can send the error. All the warnings, errors should be clear and adequate to identify the problem. The log should be monitored for the suspicious activity, especially the logs of application and APIs. Also, the logs should be stored centrally to remove the dependency on a single server where the logs are stored locally. Or the alerts should be set with the proper threshold, and the response escalation processes should be effective. The applications should be able to alert the active attacks in real time or in real time. Request forgeries. Let's see the first one. The server-side request forgery. This flaw refers to redirection to third-party sites. It occurs whenever a web application is fetching a remote resource without validating the user-supplied URL. It allows an attacker to coerce the application to send a crafted request to an unexpected destination, which is even protected by firewall, VPN, or another type of access control list. We can use Django to control this redirection by various approaches. It can be by sanitizing and validating the input data, or enforcing the URL schema and maintaining a positive allow list. We can disable the HTTP redirection altogether, or we can make sure that URL is consistent to avoid any kind of attack like talk to or race condition. The next common web security vulnerability is cross-site request forgeries. This type of attack is commonly used to spoof actions of legitimate user and involves sending unauthorized requests with authorized cookies. Anti-CSRF tokens are widely used to make sure that GET requests are not changing the state of any entity in the database. Also, using the cookie setting, the same site attribute, setting it to strict is one of the common techniques to mitigate the CSRF attacks. Django also provides a CSRF token to make sure that any operation Django provides CSRF token to make sure that any operation that make a modification to database has a unique value and it is only known to system, and which confirm that user is intentionally using the application to perform the application. The built-in CSRF protection middleware also make it extremely difficult to launch a malicious attack. By default, this middleware is enabled in setting, but if you must disable it, make sure to use these tags within your form elements. Another rule of thumb is to have proper expiry for cookies and access tokens, so that even if attacker managed to obtain the cookie, it should not be able to use it against any of the servers. In conclusion, Django offers many security-minded functions right out of the box without sacrificing ease of development and integration with both front-end and back-end component. Although by no means comprehensive, following the suggestion in this talk and following a security-minded development process can help protect you against any data breaches. As a web developer, using a framework that guarantees the security is always great, but it is even better to measure all the vulnerabilities involved while building the application. I hope this talk was able to provide great value to all the engineers listening here. And if you have made it to this point as a simple enthusiastic, it is much appreciated as well. Thank you. Have a great day ahead.